Welcome to the video for Unit 6, Day 5. Today's topic is complex fractions, and this is just a little skill to help review some basic fraction skills, but also to set you up for next week's equations. Let's start with a quick little review. There are three basic processes that you'll have to keep straight when you're working with fractions, and those are adding and subtracting, multiplying and dividing. When you add and subtract fractions, all you need to do is add the numerator or subtract the numerator, obviously. And the important part is that you keep the denominator the same. But what that means is that you first need a common denominator. So for example, if I were to add 1/4 plus 5/3, before I can add the two numerators, I need to get a common denominator on the bottom. In this case, 4 and 3 can both be turned into 12. They're both factors of 12. And I would do that by multiplying 3 times the top and the bottom of the first, and 4 times the top and the bottom of the second fraction, so that it will turn into 3 over 12 plus 20 over 12. And now that I have the same denominator, I can go ahead and add straight across to get 23 over 12. And it's worth checking real quickly that that can't be simplified, but in this case it can't, and so that's your final answer. Similarly, for the second example here, we have denominators of 4 and x, so before I can add or subtract, I need those to be the same. And I achieve that by multiplying x times the first fraction on the top and the bottom, and 4 times the second fraction on the top and the bottom. When I do this multiplication, that becomes x squared over 4x, and I'm still subtracting, and 20 over 4x. Now that I have the same denominator, I keep the denominator the same. And I'm going to go ahead and subtract the top terms, but since they're not like terms, there's no actual adding or subtracting to do. You just put them together, and that's your final answer, just like that. Multiplying fractions is the easiest fraction skill. All you need to do is multiply the two tops and the two bottoms. So in this case, x times 5 would be 5x, and 4 times 3 would be 12. And again, you just want to confirm that there's nothing you can simplify. Dividing fractions is where people tend to trip up, not because you don't know it, but because there's an extra step. So yesterday we talked about KCF, keep the first fraction, change division to multiplication, flip the second fraction. Lots of people forget to do that because they're moving too quickly, so pay attention. Here's what it looks like. X over 4 is the first fraction, so I keep that the same. And then instead of division, I'm going to rewrite this as a multiplication problem. And that allows me to flip 5 over 8 to become 8 over 5. Now that I have a multiplication problem, this is easy. All I need to do is multiply across the top and the bottom. But I actually see something else that I want to do first. Whenever you have numbers that are in the numerator and denominator that can be simplified, I always recommend simplifying as early as possible to avoid getting really big numbers later on. So in this case, 8 and 4 can be simplified to 2 and 1, because that's what 8 over 4 equals. Now I go back to where I was, which is multiplying two fractions, and I multiply x times 2 to get 2x, 1 times 5, over 5. And that's your final answer. Take a moment to make sure that you have these examples straight in your mind, because then we're going to step it up. So today's skill is simplifying complex fractions. And a complex fraction is an expression with multiple layers of fractions. So look at example A, and you'll see what I mean by this. In this example, we have a large fraction, and within that fraction, there are fractions on the top and on the bottom. Remember, in order to solve this, that a fraction is the same thing as division, and that's really the key step that we're going to take. The process I'm going to follow is laid out for you on the left-hand side of your worksheet, and you can follow along as I do this example. First step is to simplify the top and the bottom of this fraction. In this case, the top, or the numerator of the main fraction, is an addition problem. I see that I already have common denominators, so I can go ahead and add the numerators. 5 plus 9 is 14, and I keep 12 the same. As I simplify the top and the bottom separately, I'm going to keep them in fraction form. And actually, before I can add and then denominator, I'm going to need to get like denominators. And I can do that by multiplying the second fraction times 2 on the top and the bottom, making an equivalent fraction. So the bottom turns into 1 over 6 plus 4 over 6. And now that I have it like that, it's easier to add. At the same time, I'm going to simplify the top because 14 over 12 can be simplified to 7 over 6 if you divide by 2. And on the bottom, now that I have it simplified out, I have 5 over 6. And here's where the key step happens. So it's real important that your middle fraction line is clearly the largest one, because the next step is we're going to take that fraction line and we're going to rewrite it as a division problem, because that's what it really means. In particular, this fraction means that we're dividing 7 over 6 by 5 over 6. So I can write it just like this, and this is exactly the same thing. Okay, but this is an easy problem now. You keep the front, change division to multiplication, and flip the back. At this point, I have kind of two options. I could multiply straight across and then simplify, or I can recognize that 6 over 6 divides to equal a positive 1, and so really what I'm going to get is 7 times 1, which is 7, over 1 times 5, which is 5. And that's your nice final answer. Let's try another example. Example B is slightly different because you have variables, but the process is basically the same. And my first step is still to simplify the numerator first. So I have a over 25 and a over 5. To get a common denominator, I'm going to multiply times 5. And that turns into a over 25 minus 5a over 25. As I simplify the top, I'm going to be sure to keep bringing over my main fraction as well as the denominator so I don't accidentally miss that half of the problem. The next step is pretty straightforward. I subtract the numerators, keep the denominators the same. A minus 5a is negative 4a over 25. And that's all over a over 10. And here comes the big step. We're going to turn a fraction with fractions into a division problem. So what we really have is negative 4a over 25 divided by a over 10, which simply equals negative 4a over 25 times 10 over a, because I flipped the second fraction. From here, I can simplify a couple things. First of all, 10 and 25, that's the same thing as 2 over 5. And a divided by a will also cancel out to be positive 1. Multiplying everything that's left, I get negative 4 times 2, which is negative 8, over positive 5. We'll do one last example, and then you'll have some practice on your own. Here's example C. In this case, I don't need to simplify the numerator, at least not at the beginning, and I'm going to go straight for the denominator. And be a little careful with these variables and denominators. So if you think about it, x and 3x, if you really want a common denominator, the best common denominator would be 3x. You might be tempted to multiply times x here and times 3x here. You will still get a correct answer. It'll just take a couple extra steps. So the simplest thing to do is times 3 times 3, because here's what you get. Well, 3 times 6, that's 18 over 3x, and just like that, we have our common denominator. Once I have the common denominator, I can subtract the numerators. Again, I'm keeping x over 4 the same on top. 18 minus 2 is 16 over 3x. And here's the big step. We turn it into a division problem, x over 4 divided by 16 over 3x. And then keep, change, flip. Turn it to multiplication, flip this around, and multiply straight across. Notice that I can't simplify in this case. Even though 4 and 16 are related numbers, they're not on the top and the bottom, so you can't cancel anything out. Similar, the x's are both on the top. So I just multiply. X times 3x is 3x squared. And 4 times 16, well, 4 times 10 is 40, and 4 times 6 is 24. 40 plus 24 is going to be 64. And that's your final answer. Take a moment to look at these examples if you need to, and then we'll start the next video with some practice problems.